Hello, welcome again. In this video, we will talk about dependent paired sample t-test, which is a kind of t-test statistics. And as you know, t-test statistics are parametric tests, so this is also a parametric test. Mainly, we can define dependent or paired sample t-test as we have just one sample group, we have just one sample, and we collect two different data from this sample group and two different matched data from this sample group, and we conduct analysis to check whether a difference between these two uh, data uh, depending on a sample, on a just one sample. So we can say that both data sets, data points, depend on a sample. And the name comes from this point, dependent sample, paired sample, since we have paired scores for in the dependent sample t-tests. The most famous, the most well-known dependent sample t-test example is pretest post-test analysis in experimental designs. And we will conduct a sample analysis, and we will show you how we can do pretest post-test analysis as a kind of dependent sample t-tests. And we will use a fake dataset that we will create right now on Excel program. So I have participants and their pretest post-test scores might be midterm exam, final exam also. So I write participant 1 in the second cell, and I just drag it to the end of, let's do it, 100 participants. Okay, so I have 100 participants and their pretest scores. Just let's create a dataset, fake dataset with rank between comment. So the pretest scores will lie between 0 to, for example, 70. Okay. So it assigned a value as 69, sorry, 67. So I again drag it to the end of the lists, and it assigns some values between the range of 0 to 70, as you see. And for the post-test scores, this time I will assign numbers. I will intentionally create the difference between pretest and post-test scores to find the significant difference between these scores. So this time I will assign numbers starting from 40 to 100, for example. Okay. So again, I drag it to the end of the lists. So I have just the numbers in my data set. Later, I will drag it. I will just put it to the okay. Now I have a dataset which includes pretest and posttest scores. To do paired sample dependent sample t-test, I should go to analysis on the top menu and compare means, and I will find paired sample t-tests. In the paired sample t-test, I will assign the pairs on the right side. So the first thing is pretest, and the second variable is post-test. In the options, as we know the confidence interval and 0.05 level of significance value as a default, we exclude case analysis by analysis again. So just click OK. Now you will see three different tables. The first one is always descriptive statistics, how many participants, the mean for pretest scores and post-test scores, and you can realize that there is a difference between the mean values, the standard deviations, and standard error of the mean is also calculated. Since the results come from the pairs, SPSS automatically calculate the correlation between these two pairs. It just show how strong the correlation between these two values. If it is really too high, it might be also problematic for paired sample t-tests. Since so we couldn't find a significant correlation between these two values. Now, when we look at the statistics about paired sample t-tests, we have just one line: the mean difference, paired differences, the mean difference. When you calculate the difference between post-test and pre-test scores, you will find this value. Standard deviation of the difference, standard error of the mean for the difference, and the confidence intervals. And at the end of the list, you will have again t-value, calculate t-value, degrees of freedom, which is -1 of the sample, and the significance value. As you can see, there's a significant difference. Since it is below 0.05, we can say that it's significant. There's a significant difference between pre-test and post-test scores in our sample. But the thing that I forgot to talk about at the beginning of before conducting this analysis, since it's a parametric tests, we should have some assumption test before conducting this statistics. And these assumptions are, if it violates the assumption test, if the data violates the assumption test, this time we should continue with non-parametric tests, and Wilcoxon's signed rank test will be the parametric tests to conduct if it violates the assumptions. The assumptions for dependent sample t-test are similar to one sample t-test, but the first thing is the dependent variable, which means the scores, the pre-test scores and post-test scores should be independent from each other. That means, for example, in the post-test scores should not come as a result of any calculation created from pre-test scores. So dependent variables should be independent from each other, pre-test, post-test scores. If we have a pre-test, post-test design, pre-test and post-test values should be normally distributed, which means normality, but also you can check, you can calculate the difference for each data entry for pre-test and post-test scores, each paired data entry. When you calculate the differences, you can also check the normality of the calculated differences. Since it meets the normality, we can also say that it fits for the normality assumptions. And as we always have, outliers or significant extreme values should not be included in the data sets. So these are the assumptions, and this is the way how we calculate paired sample t-test statistics. Thank you very much.